Has joined in on this call. Uh, Thank you so much. It's very exciting to see everybody here. So we are going to start off with the first question. Can you go over a temperature stressor with endo and exo? Of course I can. So Le Chatelier's principle states essentially that when a chemical stress is occurring, the stress is relieved by the chemical system at equilibrium to shift in the direction that relieves that stress. So with temperature, if my pencil was working, oh boy, it's going to be, there you are. I was about to say it's going to be one of those nights, is it? So with temperature, they specifically want to go over endo and exothermic. So let's consider this equation. Let's say we have A plus B is in equilibrium with C plus D. Okay. Let's say that this reaction is exothermic. By stating that the reaction, of course, is exothermic, that means that in the forward direction, right, in this direction here, it is exothermic, which means that this is the exothermic side. For endothermic, it is the reverse direction, endo. So with temperature as a stressor, when temp decreases, right, or goes down, then the equilibrium shifts to the endothermic side. So in this case, when the temperature is shifting downward, we see that the equilibrium shifts to the right. So in this case, equilibrium goes to the right. All right. With exothermic, on the other hand, right, we will use red. When temp increases, right, or goes up, equilibrium shifts to, oh boy, to the exothermic side, which of course means that in this case, equilibrium goes to the left. And that is, of course, because, there you are, because this side is our exothermic side. When temperature decreased, it shifted to the endothermic side. For the person who asked that question, or the people that asked that question, I hope that that was a sufficient response. If you need any follow-up, please, of course, let me know. The question of, is there any definition questions on the exam? I would say that there are a couple. A good hint is that if you follow what was in the study guide, with kind of, explaining the sorts of deals like what's a specific rate constant, what is Le Chatelier's principle, right? Who discovered Le Chatelier's principle, right? Those are good questions that may appear on the exam in the form of definitions. me go back to my chat. Sure. So the next question is talking about instantaneous rates of reactions. So unfortunately, I don't have a good graph as an example, but let's make one. Shoom, shoom. And we've got this nice graph that shows reactants being converted into products. And let's say this here, zoom and zoom, is my tangent line. So to calculate the instantaneous rate of the reaction, right, which is a good hint as well, is that if you see a graph, you will need to calculate the instantaneous rate of the reaction. We use the y-intercept and the x-intercept of this line. So essentially, we are finding the slope of this line. So for instantaneous, let me rephrase that. For instantaneous rates of reaction, use the slope of a tangent line. And of course, if you need a refresher of how to calculate slope, it is rise over run, or y-intercept over x-intercept. For those of you who asked that question, I hope that helped. What is the difference between an equilibrium constant and a rate law? Good question. So the equilibrium constants and rate laws show two different things. For equilibrium constants, right, oh, sorry, I need a quick water break. I'm doing this while still feeling a little bit under the weather, so you gotta compromise with me a little bit. So, an equilibrium constant. This shows the, how you say, relationship between all of the products and reactants. This can also be used to predict where equilibrium falls. Like if it falls more to the right of the equation or more to the left of the equation. Right, the equation for this, of course, is K, capital K, is equal to, we got C raised to the X, D raised to the Y, A raised to the N, and B raised to the M, where of course we have NA plus MB is in equilibrium with XC plus YD. Right, so you can use that key to help formulate where are your variables going. Now, for rate laws, on the other hand, right, these show a relationship between the rate of a chemical equation and the concentrations. concentrations of the reactants. Of course, to calculate this, we do have a rate law where rate is equal to K times A raised to the little a and B raised to the little b. A couple people on the quizzes, I do recall, did miss this part here where you do need to physically put rate equals. Rate is a variable in this case, and as such needs to be part of the equation. So in this case, let's say we have a little a plus b, a little b, and this yields whatever, right? That's how you get your coefficients and your exponents as well. I hope that illustrated the difference for rate laws and equilibrium as well. We did temperature with Le Chatelier's principle. Can you go over the first question on molarity and dilution in the study guide? Sure. Of course, I don't have the study guide here right alongside me. So again, in the future, please also put the study guide question in there so I can cite it. But we can do a dilution and molarity question here. So dilutions and molarity. So with dilutions, right, this is your M1V1 is equal to M2V2. Whereas with your molarity, that's where your molarity is equal to your moles over volume. Of course, volume being in liters. Here, in dilutions, on the other hand, volume doesn't have to be in liters as long as they are the same variable. So let's do a molarity question first. Let's say that the molarity of this solution is, so M is equal to 0.5 molar, okay? Let's say that the moles of this solution is equal to, let's say, 1.375 moles. And I want to find the volume in liters. Okay, so we plug this into our equation. 0.5 is equal to 1.375 over V. Okay. The question is, how can I solve for V now? After this, you multiply V on both sides because you can. It's just a variable with, it's just a number essentially. So we have 0.5 V is equal to 1.375. Again, divide by 0.5, and we get, once I calculate it here, 1.375 divided by 0.5, and we get V is equal to 2.75 liters, which of course is my final answer. But let's go over dilutions now. A lot of people have trouble connecting when do I use molarity and when do I use the dilution equation, and that's okay. With the dilution questions, right? These always give you 3 of the 4 variables, right? Always gives you 3 out of the 4. So if you see a problem with 2 variables given and not 3, you know you're doing one with molarity. So let's say M1, the starting molarity, is 1.375. We'll keep using that molarity. And the starting volume is 23 milliliters. Okay, volume can be in milliliters or it can be in liters as long as they are the same unit. Let's say my ending molarity is unknown, but my ending volume is 100 milliliters. Okay, Now I plug this into my equation. We've got 1.375 times 23 is equal to 100 M2. Okay. Divide by 100 on both sides. 1.375 times 23 divided by 100. So that means my new molarity, M2, is going to equal 0.316 molar, which of course is the final answer. I hope that helped the person who asked that question. Can you go over number 26 on the study guide? Again, please put the question in there. I'm happy to go over it. Is the rate law written differently for unbalanced equations? For example, on the study guide, the unbalanced equation had the layout rate is equal to brackets K. No, there is no different layout for the rate laws if it is an unbalanced equation. The only thing with the unbalanced equation that you do need to remember is that the rate law does need a balanced equation. That's why I balanced it on the study guide. The reason why K was on the back is because I forgot to put it in on the first time, and so on my read through, I put it there and didn't move it back. So it was just a small mistake on my part. Are the questions on the test going to be the same format / structure on the Alex questions? Sure. So some of them are. So for example, I pulled some from the last quiz and changed some values around. I pulled some from the Alex homework. So there's a good mix of, my questions, Alex type of style of questions, and overall, it's a very good mix, and you should, everybody is very well prepared for this exam. Can we go through a dilution problem, and can we do a rate problem on a graph? We did that, we did that. Can you please answer this question on the study guide? Sure. Give me a minute. Let me figure out how to do this. So the question that they are referring to is question 30 on the study guide. Unfortunately, of course, I don't have the study guide right here. Actually, sure. So let's go over question 30. 9 and 30. I'll just erase these for now, sure, and we'll get back to them. So to tackle this format of question, the first step is to determine the rate orders, which of course are here and here on your equations. So reaction order for SO2 is of course 2, and when there's nothing there, it is implied there's a 1. The overall reaction order is just all of the orders combined, so it'd be an overall reaction order of 3. Here's where it gets a little tricky, and here's where you need a little bit of fancy footwork. With this one, right, it's saying that we are decreasing the concentration by half of the H2SO4. Okay, for that, we need to go ahead and just plug in 1/2 in place of the H2SO4. So when we plug that in, we get 1/4. Okay, halfway done. After this, you multiply by the rate, which of course is given here. So we 1/4 times 3.74. So 0.25 times 3.74. And I get the new rate is equal to 0.935 M over S. Of course, one more question. This question, it looks a lot more complicated than it really is. This question uses the rate law. And that rate law, of course, is given to you up at the top. So we just plug in these values. 5.44 is equal to K, because that's what we're trying to solve for, times 0.214 squared times 1.84, and that's without a square. So of course, we need to isolate k. To do that, we divide both sides by whatever that is, 2.14 squared times 1.84, and we divide on both sides with that. So we get 5.44 divided by the, oh, we could do this better. We get 5.44 divided by 2.214 squared times 1.84 for a grand total of 64.6, and that would be K. Again, don't worry about units for K in this case. It's more important that you know the process in which to get there. For the person who asked that question, I hope that was sufficient. Let's get back to these notes. What's the difference between the initial rate of the reactions and the average rate of the reactions? Okay, we went over instantaneous rate earlier. For the average rate of the reaction, that's where you have sort of these tables, right? So you have tables with some values, and right? Let's say that this is A, B, C, D, and this is 10 and 20 seconds. Let's just do this really nice and easy. Sorry, we should do this instead. There you go, all fixed. 3.000 and 0. And let's say this is 0.667. Let's say this is 2.334. We could say that C is 0.334, and we have D being 0.664 or 667, sorry. So for the average rate of the reaction, right, that is kind of, you look at 2 points in this table and determine the rate of the reaction from there, the average rate. And to do that, you use this equation. It's a little bit modified than how I explained it in the PowerPoint, but I think this one works just a touch better. We have, we've got delta change over delta time, of course, and then you take the absolute value of that, okay? The reason being, of course, is, right, and we'll put this as a star, rate cannot be negative, ever. Think of it like speed, right? When you go forward, you're in a positive speed, of course, but if you reverse, the speed is still positive, it's just in a different direction. So let's do A. So let's do the average rate for A. Okay. So we've got delta change, which of course means final minus initial. So we've got 1.00, oops, sorry. We've got 0.667 minus 1.00 over 20 minus 0, okay? So, of course, when you do that top one, 0.667 minus 1, you get minus 3.333 over 20. So when you do that, divide by 20, and you take the absolute value, your rate is equal to 0.667, technically, 7, and that'd be moles per second, or not moles per second, molarity per second as your final answer. You follow that process for the same types of questions that you see on the exam. I do see this next question where it is how many multiple choice and short answer questions where there will be. We'll put this right here so it's right at the top. For multiple choice, there are 15 questions. For a short answer, there are 9 questions. And finally, time is 60 minutes. The reason why it's 60 minutes is because the blue days are actually taking it on a Wednesday, so they only get 60 minutes. So the exam is designed to be finished within that 60 minutes. For those people who are on a red day and do qualify for extended time, for those of you who for those of you who do, you already know who you are. You will be taking that extended time in the classroom following the exam. So you will be testing for the full 90 minutes, whereas everybody else will be testing for the full 60 minutes, and you'll just be in the same room. Can you go over changes in the equation, a change in the equation where there's a smaller amount of products and reactants? I'm going to assume you meant equilibrium. And yes, of course we can. Just quick coffee. So let's say for concentration and equilibrium, let's say, right, we've got our, of course, generic chemical equation, A plus B is in equilibrium with C plus D. It's such a great chemical equation, I know. But with this, what would happen if, say, B was removed? Not removed totally, but removed to a point that it disrupts the equilibrium. So the stress is going to be remove some of B, of B while at equilibrium. Okay. If we remove some of B while at equilibrium, a couple things happen, right? There is changes for A, C, and D. When B is removed, D and C both go down, right? They've got to work harder to replace the B that was removed. But they also produce A, so A will go up. That's how we can determine the change. It also works in the, if you take away a reactant or take away the other product, or you take away the other reactant and you add a reactant or remove a reactant, right? Works in a very similar way. So here, there would be a shift to the left. Okay. What would an example of a equilibrium question be on the exam? I can give you a somewhat of a question. So let's say you've got this chemical equation. Let's say we've got H2 plus O2 is in equilibrium with H2O. Okay. Let's say what would happen to the hydrogen gas if I add some O2, right? That'd be a good example of a multiple choice question. Your choices could be it goes up or down or nothing. So of course, when you add a reactant in this case, the other reactant goes down. So the correct answer for this one would be going down. Can you go over to find the rate of the reaction on the graph? We did it. How many equilibrium questions are on the exam? For the chemical equilibrium section on the multiple choice, there's 4. And then on the short answer, there's about 3-ish. You can't give away all the secrets to the exam, but I can give away some. What do you mean by think about what makes it change / not change when referring to the specific rate constant, of course. So when explaining this specific rate constant, it is all about kind of what makes it tick, right? What gives an equation a new specific rate constant? For those of you who know, right, each reaction at every temperature has a different specific rate constant, right? The only caveat there is temperature, right? So everything else, concentration, surface area, the presence of a catalyst, right, all do affect the reaction rate, but not the specific rate constant. That's what I mean. Hello, Mr. Boos. Can you do this problem for the study guide? Calculate the molarity of a solution by dissolving 25 grams of calcium chloride into enough water to make 500 milliliters of a solution. Sure. We'll do another example. Those of you just joining us in, welcome, welcome. We, of course, do go in the order in which the questions are received. It's a big push at the beginning, it seems, right? I'm only on questions that have come in from 803, and I've done like 10 or 15 of them, and I've got 36 more to go. So, right, we need to find the molarity of this, right? The volume is given, right? That's 500 milliliters, but we need that in liters. So we convert equal to 0.5 liters. We need moles, though, and it gives us grams, 25 grams, which is not the unit that we need for this, right? We specifically need moles. So to solve this issue, we do a gram to mole one-step stoich problem. So 25 grams of CaCl2 times the molar mass of CaCl2, which I'm not going to lie, I do not know at the top of my head, CaCl2 molar mass. So the molar mass, of course, is 110.98. I mean, I don't know that off the top of my head, but you will have a periodic table on the exam. That's grams over 1 mole. So, of course, you just divide 25 divided by 110.89 for N to equal 0.2252 and some other stuff. Again, I don't like rounding until the very last step. So that's what those little dots mean at the end. So if M is equal to N over V, or molarity is equal to moles over volume, we've got the 0.2252 ... over 0.5 liters. So we just divide our answer by 0.5, and we get M is equal to 0.451 molar, which of course is our final answer. There was a question on Alex that was asking you to predict the millimoles of chemicals during a change in equilibrium. Can we go over one of those scenarios? We will actually not cover one of those scenarios because millimoles is not going to be on the exam, nor is micromoles or any variation of molarity, sticking straight with general molarity, moles over liters. Will we have to define a specific rate constant? Yes, you may need to in like a multiple choice question or in a short answer question. But can you explain the effects of increasing and decreasing pressure? Sure. So let's go over pressure. So with increasing and decreasing pressure, we have a couple things that we need to discuss, right? This mainly works for gases, right? With gases, we can easily compress and, we can easily change the volume and the pressure. Another thing is as pressure goes up, volume goes down. We've got Boyle's law to thank for that. And when pressure goes down, volume goes up. Think about the syringe, right? As you push the syringe into your finger, pressure goes up, volume goes down. When you pull it, the reverse happens. So as pressure goes up, it shifts to the side with the lowest sum. Now, what do I mean by lowest sum? Let's look at an example, right? We'll look at the Haber process. 3H2 plus N2 yields in equilibrium 2NH3, okay? So with 2NH3, right, the sum on this side is 4, 1 plus 3, and on this side it is 2. So in this case, equilibrium would shift to the left. Now, as pressure decreases, equilibrium shifts to the side with the highest sum. So again, in this case, with the Haber process, we will duplicate this. Right? It would shift, of course, to the right because it's shifting to the side with the highest sum. Do we need to know the different equilibrium symbols for each of the stressors? No, don't worry about it. For molarity and dilutions, when will we need to find millimoles? A good question. You won't need to find millimoles on this exam, but a good way to know what you need to find, right? Dilutions give you 3 of the 4 variables, whereas with molarity, it gives you 2 of the 3 variables, right? So that is a very, very good indicator of which equation you need to use. Can you give an example of a question for the change in temperature? Sure. It's very similar to like this one. So like if the reaction is exothermic and I increase the temperature, what happens? Right? Or if it's endothermic and I increase the temperature, then what happens? Right? That is a good example of a multiple choice question or a short answer. What is a delusion? I'm going to assume that means dilution, not like a mental delusion, but that's okay. So with dilutions, right, that's where you have a specific molarity of something, right, and in a specific volume, and you add something to it to make it less concentrated. Think of cleaning supplies as a good example. Let's say like you have a bottle of Windex at your home, right? And it's running low and you don't have time to go out to the store, but you need to clean all the mirrors in your house or all the windows. So you take water and you fill the bottle up to the top and you go shake, shake, shake to dilute the remaining amount of Windex that is in the bottle to fill up. And that way you can use it at least to clean those windows or mirrors. I remember I had to do that when I was growing up in an effort to save money. But when you clean them, right, or when you did that process of adding that water, you did a dilution. What do catalysts do for Le Chatelier's principle? Great question. Catalysts with Le Chatelier's principle do nothing. Catalysts only affect the rate of the reaction. It is technically a chemical stress because you are adding or removing something at the system at equilibrium, but it only affects the rate, right? And the rate gets in the catalyst affect both the forward and the reverse rate. So not really anything. How can you tell which side of a reaction is endothermic or exothermic? Great question. The question will state this reaction is blank. When it says this reaction is blank, in this case exothermic, we know that the left side is the exothermic side, right? And that means that the other side is endo, right? One side is exo, one side is endo. Same thing with endo, right? If it said this reaction is endothermic, this would be the endothermic side. This would be the exothermic side. Do we need to know what the equilibrium constant shows? Like if it's greater than 1, the reaction favors the products. Might be good to have in your, like write on your periodic table when you get it, just so that way you have it just in case for the exam. If the reaction is exothermic, does that mean the reactants parts are exothermic, the reactants release heat? So it's a similar question about temperature. Again, temperature is a very hard concept with Le Chatelier's principle. So with that, right, again, think about it this way. As temperature increases, it goes to the exothermic side. When temperature decreases, it goes to the endothermic side. Keep that in mind and just keep that idea in your head. No, feel better, Mr. Booth. Oh, thank you. Thank you for making the effort while you're sick, Mr. Booth. Oh, I appreciate it. Thank you. Can we please go over question 5 from the study guide? Sure. I just found out that that I can change between them. No, it's a game changer. Okay, so we actually did a similar problem with this one. I'm going to cheat a little bit and keep the molar mass so I don't need to Google it because I don't have a periodic table next to me. I may be a chem teacher, but I don't have chemistry everywhere in my house. So we've got 10 grams of potassium nitrate. With the 10 grams of potassium nitrate, we need to convert that to moles. So we've got 10 grams times the 1 mole over 101.10 to equal whatever that is, 10 divided by 101.10, and we get 0.09891 ... Great. Here, it says that the total volume is 250 milliliters. Of course, being the smart chemist that you are, we know that we can't use liters. We can't use milliliters. We need to use liters. So to convert this, of course, use King Henry die by drinking chocolate milk, Mike, to 0.25 liters. Okay, so now we take the 0.09891 ... divided by 0.25 liters. So just divide our answer by 0.25, and we get this equal to 0.396 molar. I hope that helped. here, we'll go back to it just in case if you need to see it one more time. It's the same steps that I took on the key to the study guide that is posted in the Schoology. Quick coffee break before we get rolling again. It does look like we may bleed over with time. That's okay. As a general rule of thumb, if you send your question after 9 p.m., I will not answer it, but any questions asked before then are going to be answered. So we'll stay until as long as it takes. Can you go over the change of pressure and its effect on equilibrium or removing it? Sure. We discussed it earlier, and we discussed it here. When a element is added or removed, how do you know which way the equilibrium shifts? Great question. Unfortunately, it may just be a form of memorization that you may need to do. But let's look at this one. A general rule of thumb, right? Discounting, of course, discounting the stress, right? So just imagine like we're discounting B in this calculation. Which side is going up? So which side is having an increase of the products or the reactants, right? Whatever side is getting more of something. In this case, A is getting more. That's how I best define it, right? If you discount B or whatever the stressor was, you look at which side is getting an increase. What would a equilibrium constant expression or question look like? I would give you a unbalanced chemical equation or a balanced chemical equation and ask you to write the equilibrium constant or solve for one of the unknown molarities. Oh, well, we can definitely do a question like that because the next question is also asking that. How can we do a equilibrium expression question and solve for one of the elements that is unknown? Okay, great. Let's say we've got this generic chemical equation, 2A plus 3B is in equilibrium with C plus 2D. Okay, using the equilibrium expression from the top of the top of this guide, we have K is equal to. You can actually do one better than this. Sorry about this. So we have K is equal to Y. We've got bracket C, bracket D with a square, because of course D has a coefficient of 2, over 2A squared, and then C, and then B, with a cubed. Okay. So let's say you are provided with these molarities. Let's say A is, I don't know, 1.315 molar. B is unknown. C is 0.75 molar. And D, let's say, is, I don't know, 3 molar. I don't know, I'm just pulling these numbers out. Anyway, so all we do here is take all of these and plug them into the equation. That's it. So to do that, and then solve for the unknown using algebra. So we have, and then let's say K is 1.375. I don't know. So 1.375 is equal to, we've got C 0.75 times D 1.375 squared over A 1.3, oh, what am I doing? 3 squared, that's better. And 1.5 and that is squared times b cubed. Okay. We solve this by using algebra. So rather than showing out that entire process has been shown on the study guide, we're going to move to b is equal to the cubed root of, we've got 0.75 times 3 squared, and that's over 1.375 times 1.315 squared. Okay, so again, I put that in my calculator. To get to the cubed root, you use the math function on your calculator. Like there's a button literally called math, and it's one of those in there. We'll put it in as a fraction, 0.75 times 3 squared, and that's over 1.375 times 1.315 squared. And I get B is equal to 1.42 molar. For those of you who would also like to see that algebra done, part of the reason why I'm not doing it is because we are running a little bit low on time, and I want to make sure I address all these questions in a timely manner. Please send me an email. I'm happy to draw out a better picture for you. Can you go, what are the aspects of the graph that we use for an average rate and the instantaneous rate? Great question. For your graph, it will always, always, always be for an instantaneous rate of the reaction. In this case, I'm not going to ask you to do an average rate of the reaction on a graph, but only do an instantaneous rate. So in this case, right, it is the y-intercept over the x-intercept. When we do the average rate of the reaction for a graph, good question. We won't do it on the exam, but great question. We did this next one. If you dissolve 10 grams, can you do an example on what if the concentration of N2 is halved? Yep, okay, we did that. Should we focus on exo and endothermic reactions and how they are decreased? Sure. I would focus on all the aspects of Le Chatelier's principle, kind of what makes reactions tick while at equilibrium, right? What makes them go up? What makes them go down, right? Keeping all those in mind really allows you to, think about what's going on with the equation. But in essence of your question, yes, you should focus on them, and you should focus on all of them. Are there questions on the exam where we have to use the molarity questions and the dilutions questions on the exam? Great question. Yeah, they are similar questions to the questions that we've done so far in this review session, right? They are similar questions to, right, these ones. Yep, these ones, sorry. Or the ones that we did up at the top, where I give you a couple of the variables and then you need to solve for the unknown. There's also a couple in there that you will need to do your stoic with, so keep that in mind as well. Can you go over the common mistakes with equilibrium? Sure. There are quite some big potholes that you can fall in, unfortunately. Mistakes with equilibrium. Right? Incorrect shift. That can be mitigated by analyzing which side is getting more of something, right? With discounting the stressor. Incorrect. How to put this? Incorrect increase or decrease of products / reactants a good mitigation tool for that is kind of thinking about, if you add or remove something, what is doing the work to make it up, or to fix that equilibrium. Those are the big two common mistakes, especially related to Le Chatelier's. I guess you could also put one in there with the equilibrium constant, right? Just incorrect calculations / putting into your calculator. So those are some common potholes that I see students fall in. A quick water break before we continue going. All right. Will the multiple choice questions be all vocab based, or will there be some math problems where there be 4 answers? Good question. There's a mix of both. There are more math problems than definition problems on the multiple choice. So keep that in mind. But there are some vocab and there are some math problems in there. Will there be any questions where on the multiple choice where there are 4 rows that relate to equilibrium? Yeah, there's going to be a question similar to like this one, right? What would happen if I add H2? Sorry, what would happen to the H2 if I add some O2, right? And you just need to determine what, does it go up, does it go down, or does it do nothing? Will we have to find the average rate of the reaction on the graph? No. Do we only need to know how to find instantaneous reactions on the graph or know anything else? No, instantaneous. Can you go over the common mistakes? Why was 20 used? I guess I'm not sure what you mean by 20. I assume you mean from an earlier question. But yeah, I guess I'm not sure. Please send me an email as a follow-up. I'd be happy to kind of walk you through where you got lost on that one. How many total questions? Of course, on the exam, there are 15 multiple choice, 9 short answer with a grand total time of 60 minutes. If the equilibrium constant is greater than 1, K is greater than 1, what does that mean? Sure. So knowing that is, could be helpful for the exam. I would refer you to, let me find it on the PowerPoint, slide 114 on the PowerPoint. So slide 114 essentially explains kind of what happens with K, right? What does K mean? So we can do a quick recap here, right? Talking about K. I also, looking at the time, it is 9 p.m. So again, any questions asked after this point may not get answered, but any questions that are leading up to this point will be answered. So we will stay, again, as I said, as long as it takes. So K, right? If K is equal to 1, right? Products and reactants are not favored. Now, what do I mean by that? By something being favored, right? Think about it as a shift, right? They will get more stuff when at equilibrium. When K is less than 1, when K is less than 1, it favors the reactants. When K is much greater than 1, or apologies, when K is much greater than 1, think like 1,000. Or is much less than 1, what am I saying? Much less than 1, think of like 1,000, highly favors reactants. Of course, the opposite, if K is greater than 1, it favors products. and of k is much greater than 1, Let's actually fix this because that was incorrect. Quick correction, 0, 0, 1. This is 1,000. Apologies for that. It greatly favors the products. So keep those in mind. It is a very good thing to have in your back pocket. It may be something good to as well to maybe put on your periodic table as soon as you get it. Do we have to know which way it goes when k gets bigger or smaller? Good, we just answered that. We're getting to the questions that have been asked at 8:30, so we're moving pretty quick. Can you go over when pressure is added or removed? We did. What happens to H2O? I assume you are referring to this one. If you added H2O in this case, H2O would go up. Or if you added O2 in this case, H2O would also go up, right? To relieve that stress, right? To relieve the stress of the added O2. Can you go over rate constant? We did. If you had to define a specific rate constant, how would you do it? Okay. Let's go here. I know we did it. So the rate constant, this is a good place to do it. Do it in green, shum, shum. So rate constant. With rate constant, essentially what it is a proportionality. Oh boy, I don't know if I can spell that word right now. Proportionality. We're just going to abbreviate it to a PORP. Proportionality constant. In other words, it relates the rate and the reactance. For the exam, don't worry about units for K. All right, don't need to worry about it. Makes it nice and easy. If you have a pressure question, how does the right have a higher sum? Okay, sure. Okay, so you're right. It's my sick brain that has flipped these two. Good eye, you. The person pointed out that I did have these flipped, and that's okay. That's why these students are amazing, and feel free to point out my mistakes. Can you go over the different stressors of equilibrium and how they affect the other side of the equilibrium? Also, what is a shift mean? We covered what is a shift, and we also covered almost all of the stressors, right? We covered concentration, we've covered pressure, and we've covered temperature. Can you give an example of pressure as a stressor and what would happen if it shifts? We gave an example here, kind of with the Hawley process, or sorry, the Haber process, my apologies. And in this case, we have, pressure shifts to the side of the lowest sum, in this case, NH3. When pressure decreases, it shifts to the side with the highest sum, 4 on this side. How many temperature questions are there? I can see everybody is very concerned about temperature when I guess I see why. Semi 1. Like 1 to 2. So don't stress too much about it. How would you solve questions 26 through 29 in the study guide? Let's hop over to the study guide real quick and take a look-see. 26 through 29. Okay, so I kind of went through it on the study guide, I thought pretty clearly, but I'm happy to go over it. Essentially, this is the equation that you'll need to use for these first two ones. Now, again, you are always relating whatever it is to the top row, right? So even if it's this one down here, you're relating it to the top row. So you do new over old, right? That's what it is here, raised to the order. It tells you the order in the question. So with new over old raised to the order, you multiply by the rate 3.71, and we get 2.87. So with the next one, of course, this one is, these two are the same, so we ignore them, but now these two are different. So we do new over old raised to the order, which of course in this case is second order. Times, of course, 3.71 for a grand total of 1.14 times 10 to the negative second molar per second. Good note here, you do need to have the units in these as well. So there are some that you don't need units, there are some that you need units. Ks, don't need units for any of the Ks. Everything else you need units for. For 3, it's a little bit more tricky. And by 3, I'm talking about this one because both are changing. So you do your first step first, right? New over old raised to the order. Okay. So we have got this here, raised to the order. Secondly, we do the same thing with this other one. New over old raised to the order. And finally, we multiply by the initial rate. If you noticed, we've been using the initial rate for each of these questions. And that's because if we used one of these different ones down here, what if one of those were wrong, right? If you got them wrong, then everything else would be screwed. So why risk it? So go with the one that we know for sure, the one that's typed at the top in the first row. So, of course, you multiply here, 2.27 molar per second. Can you go over influencers and inhibitors to reaction rate? Yes, I can. I'm surprised that question hasn't been brought up so far. I'm going to mute myself really quick. I'm going to cough really quick. All right, sorry about that. We have a reaction rate influencers / inhibitors. So something that influences it, and by influences it, I'm meaning, right, increases, and inhibitors, of course, decrease. So let's talk about influencers. And not like those influencers that you see on the YouTube or whatever, right? Let's just talk about the chemical ones. Increase in temp. Increase in concentration. Increase in surface area. And the presence of a catalyst. If you notice, right, for all the influencers, they're all increasing. Right? Each of these are increasing versus in inhibitors, they'll all decrease. So let's go over that right now. Decrease, inhibitors. They all decrease, right? Decrease in temp slows down the reaction. Decrease in concentration slows down the reaction. Decrease in surface area, again, slows down the reaction. A presence of a inhibitor, right? Those are the opposite of catalysts. So again, all of these, right, a good way to remember it, they're all negative things. right? Negative temp, negative concentration, negative surface area, right? Those all slow down that reaction. So that's how I like to remember them, right? Influencers speed up the reaction, right? And they all go up. With inhibitors, they all go down because they slow down the reaction. Can you go over the question 7 on the study guide? How many moles of H2SO4 are present in 250 milliliters of a 0.4 molar solution? Sure. So we have molarity is equal to N over V. So we have, it looks like we've got our molarity here. M is equal to 0.4 molar. Volume, of course, is equal to 250 milliliters, but we need that in liters. So 0.25 liters. N, of course, unknown. All right. So 0.4 is equal to N, or sorry, whoa, boy. Yeah, equal to N. There we go. N over 0.25 liters. So of course, to get N by itself, 0.25. So we got 0.4 times 0.25, and we get N is equal to 0.1. Oh, not molar. Oh my goodness gracious. Moles. And that's how we solve for question 7 on the study guide. Do you have to balance before writing an equilibrium constant? That's a wonderful question. Yes. For any equilibrium constant, your equation must be balanced because we use the coefficients that are there as the exponents, right? See how the N here, right, goes to the A, M goes to the B, right? X goes to the C, Y goes to the D, right? All of these require a balanced chemical equation. Keep that in mind. Oh my goodness gracious, this one's a multi-tiered one. In your own words, define equilibrium with regards to chemistry. Okay. Equilibrium with regards to chemistry. We'll make a small section over here. Equilibrium. Definition. This is basically when the forward rate is equal to the reverse rate. So when both rates equal, that's when the equation's at chemical equilibrium. In your own words, describe Le Chatelier's principle. Great question. Essentially, a reaction shifts in the direction that relieves the stress that was caused by a stressor added when at equilibrium. List all possible chemical stressors. We've listed most of them here, kind of with concentration, with pressure, and with the temperature. The rest of them should fall into place, especially if you follow, because mainly the ones that we are missing now are the 7 other ones for concentration, and those are easy to do because mostly are all the same. They're like most like 2 and 2 and 2 and 2 and 2, like they go in orders of 2. Is the test going to be the same format as the study guide? Yes. When I was making the study guide, I had the test up on my other monitor here, and I made the study guide on my computer. So it is the very similar format. Do we need to know how to draw endo and exothermic graphs like the one on Alex? No, you will not. Those were really just a check to see if you remember stuff from biology. So if you if you don't remember it, that's okay. That's partly why I kind of got you back into it, because in physics, they may come back to it. Will there be short answer questions on the test where we'll have to write like 2 sentences? Yes, there are 2 questions where you need to write. How many points is this test? Last time I counted, well, I can count right now. Let's see, for points for the test, right, so 15 for the multiple choice. We've got 2 plus 2 plus 2 plus 2 plus 3. Sorry, y'all are seeing me do math here really quickly. 3 plus 2, so 10 plus 2. Plus 5 plus 2 plus 3 plus 2. So that is another 5. That is another 5. So we've got 10 plus 5 plus 5 plus 5. 25 plus 15. 40 points. Ooh, sorry, had to do that math. I didn't know that number off the top of my head. 40 points. So I can actually zoom in here. 40 points. The exam is worth. With that, all the questions have been answered. Again, thank you for joining me on this wonderful Zoom call. Apologies that it went a little bit over, but I wanted to make sure that everybody's questions got answered. Of course, the document that we've been looking at this entire time will be posted online to Schoology, as well as the recording of this little Zoom thing. That recording should be available in 15 to 20 minutes, depending on my internet connection. As always, please feel free to email if you have any other questions. I will be at school tomorrow, and I should be in room 295A by 7 a.m. And if I'm not, I'll be there as quick as I can. But of course, if you have questions in the meantime, please feel free to email. For the red day students, right, I hope you're ready for the exam. I am going to be focusing on getting your grades up to date, either like tonight or tomorrow morning, kind of during my 2-period preps. So keep that in mind. But of course, that does bring our Zoom call to an end. I'm going to stop the recording.